I will be explaining how to answer a question that has to do with a stationary hot air balloon. On the left is the diagram we will need in order to answer the questions on the right. The question tells us 3 cables are used to tether a balloon as shown. 1. Determine the angle formed by cables AB and AD. 2. Determine the angle formed by cables AB and AC. Our first step to solve the question is to form the rectangular components of each cable. We can do this by looking at the X, Y, and Z components. Looking at cable AB, we can see that the orange line shows the X component. Knowing this, we can tell that the cable is going to the left of the origin 4.7 meters. Therefore, the X component is a negative 4.7. We can then substitute this value into the X component areas. Now, the orange line shows the Y component. That as the cable goes from A to B, it goes down 8.2 meters, so it is therefore a negative 8.2 meters, and we can substitute this value into the appropriate areas. Finally, we can tell that there is no orange line to demonstrate a Z component, so there is no Z component for cable AB, seeing as though the cable never extends in front of or behind the x-axis. Since this is the case, substitute a 0 into the appropriate spots. Now that we have all of the component values, we need to find the total length of the cable. To do so, we need to square each of the values in the equation and take the square root of it. This is the same equation used as the Pythagorean theorem. The only difference is that there are 3 values being squared instead of 2. Whatever the answer is once the square root is taken is the total length of the vector. In this case, the total length is 9.45 meters. Now, we need to make the rectangular coordinates of cable AC. Looking at the orange line, we can see that the cable goes to the right of the origin 3.2 meters. Therefore, the X component is a positive 3.2 meters. As before, we must look at the vertical component to determine the Y value. We can see that as the cable goes from A to C, it goes down 8.2 meters, meaning that the Y component is a negative 8.2 meters and can be substituted into the appropriate areas. Finally, we must look for a Z component. Unlike the first cable we looked at, this one has a Z component. It comes out in front of the x-axis 5.7 meters as shown by the orange line. Substitute this into the correct blanks. Now, we must find the total length of this cable. As for the previous cable, square each value in the equation followed by taking the square root. The cable comes out to 10.487 meters. Now, for the last cable, we will do the process over again. We will start by looking for the X component. In this case, there is none because the cable does not extend to the left or right of the origin. Therefore, you can substitute 0 in for X. Now, we can look for the Y component. The orange line shows that the Y value is a negative 8.2 meters since the cable goes from A to D, and it therefore goes down. Substitute negative 8.2 meters into the appropriate places. Finally, let's take a look at the Z component. The orange line shows us that there is a Z component present and that the value is 4.4 meters. Since the cable is going from A to D, the cable is going backwards, behind the x-axis, so it is therefore negative 4.4 meters that will be in the equation. Using the same process as the other 2 cables, square each of the values in the equation and then take the square root. The resulting answer when this is done is 9.31 meters. We have now finished making the rectangular components for each of the cables, meaning that we can move on to step 2, finding the dot product of AB and AD. Cables AB and AD, I brought over their rectangular component equations so that we can easily see all of the information at once. I also added the equation for the dot product. The equation is AB dot AD equals AB times AD cosine theta. On the left of the equal sign, we will use our components for each cable, and on the right, we will use our total cable values. Knowing this, we can substitute our values into the dot product equation in order to determine the angle formed. This will read 4.7i minus 8.2j plus 0k, all in parentheses, dot 0i minus 8.2j minus 4.4k, all in parentheses, equals 9.45 times 9.31 times cosine theta. We get 0 plus 67.24 plus 0 on the left, and it is set equal to 87.95 cosine theta. Next, we can simplify by dividing both sides by 87.95 in order to isolate the variable cosine theta. When we do this, we get 0.764 equals cosine theta. Finally, we take the inverse of cosine. This gives us our final answer of 40.14 degrees. Now we're ready for step 3, dotting AB and AC to find the angle between the two. Once again, I've brought over our rectangular coordinates for cables AB and AC to better see all of the information. We will also be using the same equation to dot the two. Substitute into the equation to get negative 4.7i minus 8.2j plus 0k, all in parentheses, dot 3.2i minus 8.2j plus 5.7k, all in parentheses, equals 9.45 times 10.487 cosine theta. When simplified, the equation becomes negative 15.04 plus 67.24 plus 0 equals 99.114 cosine theta. Now we're going to isolate the variable cosine theta by dividing both sides of the equation by 99.114. After doing so, your equation becomes 0.527 equals cosine theta. Finally, take the inverse of cosine. Your answer will be 58.22 degrees, which is your final answer. You have now answered all parts of the question and hopefully understand the dot product a bit more.